What's up, Jaguars? This is one of your mentors, Dan. I've got a tool that you can use to come up with ideas for a robot. We call it a function diagram. And basically, a function diagram is a nice picture that you can use to break all the parts of the robots all the way down into what each part actually does, and then come up with different ways to perform that function. So a function diagram first starts with your overarching objective. Um, we have four different things that we want our robot to potentially do, like climbing a rope or shooting the ball into the high tower or placing gears on the airship. So pick one of your objectives that you want to design for and then create your function diagram around that. We'll do an example of putting the ball in the high tower at the end of this video. So in a function diagram, what we have on the left is we have inputs. There are three kind of inputs: energy, a signal input, and a material input. These can be things like distance, time, vision, touch for signal inputs, force, electricity, or heat for energy inputs, and for material, you can have things that your system interacts with. For example, like cars interact with gas, farming equipment does corn, and vending machines interact with money. So those are your inputs. The same kind of inputs go into our system, and they interact with all of the parts and subsystems, and ultimately we end up with outputs: energy, material, and signal. So when we're creating a function diagram, you want to first start with what are we inputting and what are we outputting and what's our total objective. Once we have that figured out, we want to go down into what our actual subfunctions are. So what you'd start with is, let's say your signal is distance. You'd want to think about what parts of the robot deal with distance, and you would write down that type of function. And I'll go through an example to make it a little bit more clear later. And so you'd fill out all of your function boxes that are associated with your signal, input, and output. Same thing with energy, and same thing with material. Now you'll notice that there's these arrows here. That's important because sometimes these functions interact with one another. Like for example, if you have a sensor that says that the ball is loaded into a hopper, that sensor would tell a motor in energy function to do some action to a ball in material. If this sounds kind of complicated, let's go through a simple example on the next slide. Okay, so I've got this function diagram here for dispensing soda. That's my goal. I have some inputs: energy, signal, and material. And then what do I get out of the machine? I just get my soda. So we've started our function diagram. We know we have three different inputs, and we get one output, and we've got our main system boundary here. So if we start with signal, I need to detect that I put the cup underneath the machine, and then I also need to detect that I remove the cup so I don't just keep spilling soda on the floor. Next, with energy, I gotta mix soda, syrup, and the water. I need some sort of energy to do that. And then I also need some sort of energy to push that soda mixture into a cup. And then from the material standpoint, I've got water and syrup that are coming into my machine, and I've got soda mixture that's going out. So finally, you've got your material that's an output. So if we look at our function diagram here, we can see that we've got two subfunctions in signal, two in energy, and two in material. And next is the design concept phase. What you want to do for each one of these boxes is just come up with different ways to detect that a cup has been placed and detect that a cup has been removed, or come up with different ways to mix the soda and come up with different ways to push the mixture into the cup. So what I did is I took two designs that are out there right now. We've got this old school style and the new school, and then in red I said, okay, how does this machine perform the subfunctions, and then how does this machine perform the subfunctions, the blue one. So we'll start with the old school. Anything that is highlighted in red is associated with that. So, from a signal standpoint, how do I detect that the cup has been placed? Well, there's a lever. It's this little black lever here. And that's the same for the cup to be removed. From an energy standpoint, there's a pressurized tank that pushes the soda and the syrup together, and it pushes that mixture into your cup. And then with these new school style, there's like an electric motor that does the work. And then from a material standpoint, on the older style, there's a water line that's fed into the machine, and then there's some bags of syrup. That's how things get mixed together. And then in the new style, there's removable cartridges. So basically what I'm showing here is that you can do the same functions in this diagram with two different designs, and it's just a matter of like figuring out ways to perform the subfunctions. So if we do this to our robot, I just came up with this for putting the ball in the high goal. We've got inputs such as energy, material, and signal, and we've got outputs of material and signal. So in this case, our inputs are things like how far away are we from the goal, what's the ball trajectory, and then energy, we have electricity from the battery, and material, we've got the ball going into our robot. Output, we've got a signal, whether that's from the robot or not, did we make a successful shot, and then we have our ball that's leaving the robot. So if I look at all of our signal functions, we have to locate the ball in the ball bin. Basically, I'm just walking through the process of how the robot would perform this function of putting the ball in the high goal. So first, it's got to locate the ball bin. Next, it's got to locate the goal distance. It's got to figure out if the ball is loaded and determine the ball trajectory. Okay, so from an energy standpoint, I've got to move the ball into the robot. We've got to transfer that stored energy into a force to move the ball, and I have to transfer stored energy to the force to move that ball. Now, granted, I'm making this assumption here that the design that we're using for this putting the ball in the high goal is just like an air gun or a spring gun or something that shoots it in the air rather than like a claw or a crane. Okay, and then finally, from a material standpoint, we have to make sure we can pick up the ball, we have to position and aim the ball, and fire and reload the ball. So notice I have all these arrows connecting. The reason why is because once you locate the ball in the bin, you have to move the ball into the robot, and then you also have to pick up the ball. So these three subfunctions are connected to one another. So these arrows just tell us that, okay, make sure that whatever function that you come up with here can be connected to some function that you come up with here. Bottom line is you can perform all these functions with different methods. So to locate the ball bin, we could use a GPS sensor. To locate the goal distance, we could use a rangefinder. To make sure that the ball is loaded, we could use a touch sensor. And to determine the ball trajectory, we could make a cool physics model. But the beauty of this function diagram tool is that it doesn't have to be just what I've come up with here. You can run another iteration and make a big list where, okay, this is the same thing. We perform the same function, but instead of using like a GPS sensor, we just have somebody using the controller to drive the robot to the ball bin, and somebody using a controller to locate the goal distance, and to make sure the ball is loaded visually, and to determine the ball trajectory visually. So if you want to use this tool, it'd be helpful, I think, and it'd help you list out a bunch of different options to perform a function. If you have any questions, let me know. Hit me up on Basecamp. Hope this helps. Thanks.